Okay, Mallory, I hope you're having a wonderful time at All-State Choir. We are in the second half of 5-2 notes. We're going to get done with these notes today. Here's what we're going to do, folks. We're going to go through example 4, and then we're going to do number 3 on your homework together. And then we're going to come up and do part 2. Okay? So, example 4, number 3, then come back to part 2. Okay? All right, so kind of 3 problems-ish, right? But there's some A's and B's. Example 4, devil of a problem. All right, let's write some information down. We know, maybe put this at the top, the formula. P of x equals, and do you have this formula memorized?
The sum of x.
Nope. NCR, P to the R, Q to the N minus R. It really has 3 parts, like this part, this part, this part that you're multiplying together, right? Okay. So 4 variables. We have an N, an R, a P, and a Q. They call R X. So don't let that confuse you if they say X, whatever, right? There he is. There he is. Do you need any of them? No? Okay. So they call their RX, which is whatever, it's fine. Let's go through here and let's pull information out and put it here and we'll see what we get, okay? So, based on a Harris poll, we're on example 4, on 5-2. I don't know. It's at the top of a page. Yeah? Okay. You kiddo.
Yes.
They don't have page numbers. Don't confuse him anymore. He's already having some problems.
In one binder.
Whatever. Okay.
How many
All right.
classes are you taking?
Okay.
Like 4.
Based on a Harris poll, 60% of adults believe in the devil. What does 60% do for me?
That tells you your
Percentage. Tells you how much of
Which one of these is 60%? 0.6. Let's call 0.6 P, okay? And right next to P, so that I can keep these things clear, I'm going to put yes, devil. They believe that the devil exists 60%. Whatever. Okay, that means Q is 0.4. This would be people who do not believe in the devil. So I'm going to put no devil next to that as an abbreviation so I can keep them situated and keep them clear, all right? And then we go down to part A. The probability that exactly 3 of 5 adults believe in the devil. Okay, so N and R.
3 is R.
3 is R.
5 is N.
5 is N. Okay, just so we're clear, if we were to make this into a table, which we're going to have to probably do part of that, for part B, we have an X and we have a P of X, right? We call it R instead of X. Okay, so if you want to call it R, that's fine. Okay, if I have 5 adults, and we're talking about believing in the devil, I could have
1, 2, 0.
0 of them believe in the devil, right? I could have 1 believe in the devil, 2 believe in the devil, 3, 4, 5, right? 5 would be all of them believing in the devil. Got it? They want to know this one right here. They want to know the 3. They want to know the probability of having 3, okay? Now, my P is 0.6. Yeah? 0.6, 60% believe in the devil. So, if I fill this table completely in, which of these rows will end up having the highest P?
No.
3 corresponds exactly to 60%. 3 out of 5 is exactly 60%, which means this P will end up being the biggest. Do you see how this works? Okay? All right, we'll fill this table in here in a second. But they want to know exactly 3, so if I fill this in just for part A, we're doing P of X is equal to NCR, which will be 5C3, times P. And P is 0.6 and Q is 0.4. Now, I have to figure out which exponents go where. 6.6 is believing in the devil. Do I want 3 or 2?
3.
I want 3 people believing in the devil, which means 2 are not, right? That's my exponents that go on there. Got it? Okay, I would, if I were you, practice typing that in. If you don't know where those buttons are, you holler at me so we can figure this out, okay? Because that's kind of a beast. Sometimes your calculator does weird things. What'd you get? Yeah? You can. You can. And subtract. 1 and 0.
I approximately got 0.3456.
0.34. Really?
34.56%.
Okay, if we're filling them in at the table, let's go ahead and leave it as point. 0.3456. That's interesting. Okay. I'm just saying that's interesting. So the probability that exactly 3 out of 5 is 0.3456 or 34%. Now that should be the highest percent on that chart, right? Okay. So that was A. The answer to A is this guy. Okay. B says the probability that the number of adults believe in the devil is at least 2. Okay. What does at least 2 mean? 2 or more, right? Including 2. Yeah. So I want to know this one. And this one, and this one, and this one, all added together. True? That would be at least 2. Or, Reese just said this. What else can you do instead? I could find this one and this one, add those together, and then subtract from 100%, right? You see how this works? And instead of doing at least 2, because at least 2 will require me to do 3 more of these, right? Versus these require me to do 2 more and then subtract. Whichever one you want. Which would you like to do?
2.
You want to do the 2 and subtract? So I want to find 0 and 1. I want to find P of 0 and I want to find P of 1. Okay? All right, P of 0 is going to look like 5C 0, 0.6 to the,
Third.
no, 0.6 to the
Oh, we need different ones.
0,
What are you doing?
and 0.4 to the, right here,
0?
5. If 0 believe in the devil, that means all 5 don't believe in the devil. Okay, and I do that, and I plug that into my calculator and I get an answer. If I set up the next one, this would be 5C1, right? 1 person believing in the devil. 0.6 to the
First.
1, 0.4 to the 4th. By the way, if you haven't figured this out yet, this guy is always the same exponent as your whatever, right? Yeah? And then these two add up to be what n is? Yeah? Okay, that was a lot of stuff. Okay. All right, what'd you get for 0? 0.01024. Okay, just real quick. 5C0 is 1, 0.6 to the 0 is 1. So if you wanted to skip all the steps when you have 0 and just do 0.4 to the 5th power, that is totally fine. What'd you get?
0.01024. Yep.
Okay, 0.01024. That was 0. 0.01024. Okay, that's like 1%, okay? Do you type in the first power? You don't need to type in the first power. True?
0. It's 0.01536.
0.1536? That's not what you got? What'd you get?
0.0768.
Yeah.
Oh wait, I forgot to plug in a number.
Gotcha.
I
Okay.
did change all
0.0768. 0.0768. Okay, that's about 7%, almost 8%, right? If I add those two together, oh gosh. I have one more decimal place than I need.
0.08704.
0.08074. Okay. I want to know part B, find the probability that the number of adults who believe in the devil is at least 2. That is the probability of 0 and 1. So 100 minus 0.08, which would be like 92%-ish, 91 and change. Point what?
Wait, what are you doing?
What are you talking about?
saying 91.3.
Oh, 91.3?
No, can you explain what you just
Isn't
did?
that what you're saying?
So this, if I add those two together, that's 0 and 1, right?
Yeah.
Okay. If I want to find at least 2, though, I want to find these. That's going to add up to be 1 minus that. If this is 8%, it'd be like 92%-ish. Right? I'm just guesstimating. So if I subtract that from 100% or 1, you get point what? 9, 1,
296.
296. Cool. Or 91.2% is the chances of getting at least 2 people out of 5 believing in the devil. Right? I have a 60% chance that any one person believes in the devil, so the chances of 2 or more believing in the devil is 91%. That's about right. Okay. Confusion? Confusion? A little bit? Okay, let's go down and do example 3, and maybe we'll clear up some confusion, okay? The first couple of these are a little weird, but it all makes sense. And I like the little diagram over here. What?
She said that you were doing
What? Yeah, we're doing number 3 on the homework together, because I know you're going to ask this question. And it kind of goes along with this. So, here we go. All right, multiple choice questions. Each have 5 possible answers. Why did they tell me that? Because that gives me,
N.
no. That gives me P. That gives me P, which is like your probability. Your probability of getting it right is 5 possible answers, 0.2, 1/5, which is 0.2. That means Q is the chances of getting it wrong, which is 0.8. So I'm going to put correct and wrong here. Okay, so I can remember which one is which. It's great that you put the numbers there, but sometimes I get my P's and Q's switched around. So it's helpful for me to always put next to P and the number what that means. So I can remember I get my exponents in the right spot, right? Okay, so correct is 0.2, wrong is 0.8. Okay, there we go. We won't use that information until we do like part C, I don't think, right? Use, okay, one of which is correct. Assume that you guess the answer to 3 such questions.
Left arm, arm.
That is N. N is 3 total questions. Then we're going to look at what's the chances that you get exactly 1 right, exactly 2 right, exactly 3 right. That's R, okay? All right, so use the multiplication rule to find the probability of correct, wrong, correct. Okay, I have 3 questions. 1, 2, 3. Correct, wrong, correct. Got it? That in that order. What's the chances that this first one is correct? 0.2. What's the chances that the second one is wrong?
0.8.
0.8. What's the chances that the third one is correct? 0.2. And what do I do with those?
Add.
Multiply them. You're multiplying. Add would be if I only had 1 question, right? I'm doing 3 separate questions, so 3 or more you multiply, or 2 or more you multiply. Okay, if you do that, what's the chances that that combination happens exactly?
0.032.
0.032, so like 3.2% chance that that combination will happen exactly. Now, this is if I'm guessing randomly. Obviously, if I have some knowledge in my brain and I studied, my chances of getting the answer correct is higher. But this is just if I just bubble straight through. Does that make sense? If you are guessing randomly on these things, right? Yes, if you guess the answer. All right, here we go. B says, beginning with CWC, make a complete list of the different possible arrangements of 2 correct and 1 wrong answer. So I have CWC. What's another one that another combination that has 2 correct and 1 wrong?
WCC.
CCW. What else? WCC. What else? That's it, right? How many are in the whole list?
3.
Like the whole list.
9. What? What are you asking?
How like
5 times.
how many combinations are in the whole list? Who said it? 8. Right? 8 in the whole list of correct, wrong, right? I could do correct, kind of like boy, right? I could do wrong, or like girl, whatever, right? Correct, wrong, correct, wrong, correct, wrong, don't write this down. Wrong, correct, wrong, wrong, correct, right? That would be the whole list of combinations that I could get if I'm guessing on all 3, right? How many of those involve 2 wrong, or 2 right and 1 wrong? 2 correct and 1 wrong. 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 Right? We just made that list. Got it? 3 out of 8. Okay? Then find the probability for each entry in the list.
For each what?
Okay? Find the probability of each entry in the list. So what's the chances that this one happens? Let's do it like we did part A, right?
1 out of 8.
What's the chances that the first one is correct?
We just did it up top.
0.2.
0.2. The second one's wrong. 0.8 times 0.2. We got 0.032, right? Okay, what's the chances that this one happens? Correct, wrong. That would be 0.2 times 0.2 times 0.8, but it's going to be the same answer, right? 0.032, yeah? Okay, this one would be 0.8 times 0.2 times 0.2, right? But it doesn't matter. Multiplying in any order is 0.032, okay? So what's the chances that any one of those 3 happens? You add them, right? Which would be 0.096 or 9.6%, right? There is a 9.6% chance that what happens?
You get 2 correct.
That I get 2 correct and 1 wrong. Not at least. At least would be a little bit different. But a 2 correct, 1 wrong in any order would be a 9.6% chance. Okay? Now, let's do this one. Based on the preceding results, what is the probability of getting exactly 2 correct answers when 3 guesses are made? We got 9.6. Okay? let's do this. 3 guesses. So N is 3, R is 2. I want to know exactly getting 2 correct, right? Okay, 3C2. 0.2 to the something, 0.8 to the something, right?
Wait, I have a question. What is that? The question before that, it's asking for each entry.
Find the probability for each entry. So this should actually have been the answer for part 2. This is the answer for part 3. Okay. If we do this guy, 0.2 to the second, 0.8 to the first, right? If I get 2 correct, that means 1 is wrong, right? 0.8 is my wrong. Okay, if I do that, what do you get here? If you do 3C2, 0.2 to the second. Oh, look at that. 0.096.
Whoa.
This formula gives me all 3 of these added together, okay? So this formula takes out of the equation the order in which the correct and wrong occur. This is just the chances of getting exactly 2 correct and 1 wrong. In any order, I have a 9.6. It does all of this work in this one formula, right? Do you see how that works?
Yep.
Okay, that's what the calculator brain is doing, right? This C is saying how many combinations are there of getting 2 out of 3 correct. How many what is 3C2? Without doing it in your calculator, what is 3C2? How many combinations do I have of getting 2 out of 3 correct? 1, 2, 3. 2 out of 3 correct. There's 3 combinations. So 3C2 is 3, and I take that times 0.2 squared times 0.8 to the first power, right? Each one of these is 0.2 squared times 0.8 to the first power, right? That's what this is right here. And there's 3 of those combinations. So we're multiplying that by 3 or adding the 3 together. Do you see how this works? Yeah? Yeah? Okay. So 0.096. Got it? That's what the binomial probability thing does. It takes out of the equation the order, right? It says in any order. That's what a combination does, right? Combination in any order doesn't matter, right? As long as I'm getting 2 correct and 1 wrong. Clear as mud? Mm-hmm. Woo! Okay, there you go. That's number 3.
Okay.
All right, moving on. Let's do example 5. Oofda. Okay. All right. Do you remember when we had X and P of X, that whole big chart, and I wanted to find the mean? How do I find the mean if I'm given the table?
Multiply.
I take X times P of X and I add them all together, right? And I take the sum. That gives me the mu or the mean, right? I do that. Okay. Then let's say I want to find the variance. Okay. Do you remember this formula?
Mm-hmm. The sum of x times mean.
No.
No.
X
Plus
minus the mu, right? I want to find how far he is away from the mean. I square it. I take it times P of X. I do the sum, and that is equal to the variance, right? And then I take the square root of the variance, and that gives me the standard deviation, right? That's how I do it if I'm given the table. That is awful and ugly, and we hated that. True? Gross. 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 Mean, variance, standard deviation, disgusting. If I'm given the table. But check this out. If I'm given my N and my R and my P and my Q and all of those things before I create the table, right? Do we know how to create the table given the N, R, P, and Q, right? Like it's what we kind of did up here, right? We could have filled that whole table in, giving the N, R, P, and Q using the formula, right? If they give me this information beforehand, I can find the mean really easily, right? The mean is going to be N times P, okay? So for example, if 60% is the percentage of people that believe in the devil and I have 5 people, on average, how many people should believe in the devil? 0.6 times 5, which is 3, right? So mu here was 5 times 0.6, which is 3, right? That should make sense. 3 was my average number, right? Okay, if I'm trying to find the variance, I take N times P times Q, which is 5 times 0.6 times 0.4. So what's the variance? I don't know, whatever that comes out to be. 0.3, 1.2? 1.2? Yeah? That's my variance. How do I find the standard deviation? Take the square root of that. What's the square root of 1.2? Like
1.095.
the square root of 1.2? 1.095? That's my standard deviation. Look how much faster those equations are for finding mean, variance, standard deviation when you're given the NRPQ stuff rather than finding it from the table.
Why do they always teach us like the long, horrible way?
Because sometimes you're not given all the NRPQ, you're only given the table. So, like, sometimes you have to do it this way. It's not like that way you can always do. You can't always do it that way. Sometimes you have to use the table. Yeah. So, if you're given NRPQ, this is the formula that you have for finding mean and standard deviation and variance.
Physics, it builds.
Yeah. Although it feels like it's building downward because we're getting to the easier stuff. I don't know why. Okay, so here we go. Using parameters to determine significance. Above we were talking about 460 overtime NFL games, right? The probability of winning, probability of losing was 0.5. So they ask for, find the mean and standard deviation, but let's focus on mean. Find the mean number of wins, right? If you have 460 games and the chances of winning and losing are 50-50, how many games should you win? 230, because the mu, or the mean, is n times p. N was 460, p was 0.5, half of 460 is 230, right? That should just make sense. That 230 should be the number of wins you get. Okay, standard deviation. How do I find standard deviation again?
PQ and N.
PQ and N, but I have to take the square root if I'm doing standard deviation. So square root of NPQ, or PQN, whatever. It is the square root of 460 times 0.5 times another 0.5, and the standard deviation is how much?
10.7.
10.7 for a standard deviation?
Yep.
Okay, that's my standard deviation. Okay, B. Use the range rule of thumb to find the values that separate the number of wins that are significantly low and significantly high. How the heck do we do this?
Is it the times 2?
Yeah, we add 2, subtract 2, right? So if 230 is my middle number, right? And I add the standard deviation twice, what's considered a significantly high number of wins?
251.
It'd be like adding 221.7 or 0.4.
It's 251.4.
251.4 if I add it twice, right?
Can't have half of the game,
Right. Okay, if I subtract it twice, subtracting 21.4 is like 208.6. Check me.
Or minusing 21.4.
Yeah.
What'd you get?
208.6?
Yeah.
Hey, that's anything below that and anything above that is considering a significantly high or significantly low number of wins.
How did we get 21.4?
Because you're adding the standard deviation twice. And if I double this, it's 21.4. So I just added, instead of adding it once and then adding it again, I just doubled it and then added it. Yeah, good question. Okay? Is the result of getting 252 overtime wins and 460 considered a significantly high number?
Yes.
Yes, it's significantly high. Why is that important to determine?
Because it's
That means that since it's a significantly high number of wins, that means some outside force is probably causing that number to be so high,
like they're
which is the coin toss. The coin toss is what's determining a high, significantly high number of wins, right? If that number lives in here, it's probably just random chance that, they had more or less or whatever. But since it's a significant number, there probably is something causing that to happen, which is the coin toss. Got it? Yes. 252 is significantly high, right? Now, we already knew that. We already knew that 252 is significantly high because we did it yesterday, and we did it with the NCR method, right? What's the probability of getting 252 out of 460? We determined that it was this one, right? And that said that because it was less than 5%, it was a significant event, right? But we also can do it another way by doing the add 2 standard deviations, right? And it falls outside that region also. So 2 different ways of determining whether it's significantly high. Got it? Okay, you can either look at it and compare it to 5%, or you can see if it's beyond the 2 standard deviation threshold.
So they call, what do they call? They call RX?
Yes.
like
So you just call it R. I don't care.
When we do NCR, that's
Yeah, it's NCX basically. Yeah. So in your homework assignment, I think number 1 is just having you identify the values. You don't actually have to do the thing. Okay, so just tell what N, X, P, and Q are. If you want to call it R instead of X, that's totally fine. But you're just identifying those values based off of that story problem. Got it? Okay, get a start. You got, yeah. You got some good ones. Okay. If it's helpful, write the formula at the top. P of X equals NCR, P to the R, Q to the N minus R. Make sure you have him handy somewhere. And I would maybe memorize that thing, actually, if you haven't already. Okay. You probably will have it memorized whether you want to or not after this homework assignment. Got it? Okay. There you go.
You had done the making me test.
No, I haven't. I'm sorry. Can we do it tomorrow?
Yeah.
Okay, let's do it tomorrow. Okay, bye, Mal.